All right, this is a 10.6. So we looked at the sine and the cosine functions and their graphs. And we're going to deal with them a little bit more next lesson when we deal with translating those functions. But now we want to look at the tangent and then the cosecant and the secant. Tangent and the cosecant and the secant. So let's start off with the tangent here. All right, so we've been saying all along that the period of the sine and the cosine. So if you guys will just look up here. Again, just a quick sketch. You don't need to draw this, just look. If I were to sketch the sine, it would look like that. And the period would be 360 degrees or 2 pi radians, right, for one complete wave. If I were to sketch the cosine, it's hard because I got to hit the points now because the sine is there. It would look like that. And again, the period would be 360 degrees or 2 pi radians for both the sine and the cosine. And they keep going on forever and ever. The tangent is not like that. So the tangent is different. And so instead of the tangent going through 360 degrees, it only goes through 180 degrees or pi radians. So the tangent repeats every 180 degrees or every pi radians. Okay, so if we're going to graph the tangent, there's really only 3 key points. I mean, you can do others and we'll do others. So grab your calculators out. Let's punch in a few values. And to show the tangent, we start at negative 90 instead of 0. And you'll see why in a minute. So punch in negative 90, hit your tangent button. And most calculators say error or syntax error. Does anybody's calculator give them anything other than that? Right, domain error. Yeah, domain error. Okay, so what is the value then in reality? It is infinity, all right? And we're gonna put down negative infinity. Okay, so that's fine. And we'll do that in a minute. I'll show you. So punch in negative 45, hit the tangent button. Negative 45, hit the tangent. And do we get negative 1? Okay. All right, punch in 30, hit the tangent button. And negative 0.5774. All right, so negative 0.5774. Go ahead and punch in 0, hit your tangent button. And that one should be 0. And then punch in 90 and hit your tangent button. And what do you think that one is? That's going to be positive infinity. Okay, so let's go ahead and do, I don't know, let's use green here. I need a dotted line at negative 90, a vertical dotted line, and I need a dotted vertical line at 90. So what are those imaginary dotted lines called? Say it if you know it. Okay, good. So those are the asymptotes, right? They're the imaginary line that the graph approaches but never reaches until it hits infinity, right? So you have asymptotes at negative 90, 90. The next one, if you want to put another one there, and go ahead, you might as well, is 270. And do you see how we're going every 180 degrees? And the point is there's 180 degrees between the asymptotes, right? The period of the wave. So the tangent's going to repeat every 180 degrees. All right, so let's go back in and let's plot negative 45. So that's going to be right there, right? Negative 45, and that's a negative 1. 30 isn't technically on your scale, so we won't even bother with it. Go ahead and plot 0, 0. And then positive 45 we didn't do, but could you guess what the value of positive 45 will be? It'll be 1. And so stick that in there. And again, our graph's going to look a little bit stretched out because it depends on how you make your scale, right? I mean, I can make my scale really, really wide, or I can make it really, really narrow. So this thing starts off at negative infinity and comes up through these points. And this should look a little bit more curve-esque and goes up toward positive infinity. And again, that's a little bit of a skew of the thought because we're stretched out on the period, but that's the way it looks. And so this thing just repeats itself in this respect all the way through. I'd have been better if I'd put the 1 and negative 1 a little bit further down and further up. But anyhow, it doesn't matter. So go to the next one and do the same thing. Go halfway between 90 and 180, right? And put the point at negative 1. Then put a point right at 180. And then go halfway between 180 and 270 and put a point at 1, and you can draw the second wave. And they just keep going, right? You're just going to repeat, 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 repeat. So again, knowing the shape of the tangent and knowing the period is really key to understanding the function. Right? Knowing the shape and such is really key. So normally we graph the tangent between negative 90 and 90. Okay, so a little bit of terminology, no big deal. The tangent isn't continuous, it's got to be discontinuous. Discontinuous. Because if it's not continuous, it's got to be discontinuous, right? It's got these breaks in it, which really messes with the domain. Right, when you guys did the homework the other night, what was the domain of the sine and the cosine? All real numbers, right? It was continuous. You had every possible x value, every possible angle. Where here, negative 90 doesn't work. It's infinity. Infinity doesn't work in calculations, all right? It just messes things up. All right, and so it's discontinuous. So how in the world do you show the domain? Well, you got to write what x can't be. So set of all x's such that x does not equal. And then you're just going to list. And the easiest way to do it is use a plus minus and stick in 90. So x does not equal plus minus 90, comma, plus 9 minus, what's the next one going to be? 270. And I need to use 3 ellipses, right? Because aren't there, like, doesn't this go on forever and ever, right? Every 180 degrees, you have another value it cannot be. So it just keeps going on. And so I need 3 ellipses to be able to show that. I need to be able to show it going on forever in the positive direction, forever in the negative direction. That's why we're doing positive and negative, right? Do you agree? Positive 90 doesn't work and negative 90 doesn't work. That's why the positive negative. So positive 270 doesn't work, negative 270 doesn't work. And so you got to include the next one, which is what, 540? 450, thank you. Plus minus 450. And now we have 3, and therefore we can use ellipses, dot, 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 because the pattern has been established, and close it off with a brace. And that is the period, the domain for the tangent. All right, discontinuous. And again, this is the basic tangent. If you look at it, there's no A value, there's no B value. We haven't changed the amplitude. We haven't changed the period. We can do all of that, but it's just the basic model. What is the amplitude of the tangent? Infinity, right? I mean, how high does the wave rise above the rest position? To infinity. So it's got an infinite amplitude, just the way it is. Okay. So let's think about the period. What if you were asked to give the period, because we've done this already with the sine and cosine. Now what if you have to figure out the period for the tangent? So what if we said give the period if f of x equals a tangent of 3b? Okay, so again, in your thinking, this 3 is telling you that there are 3 waves in every, 3 ways in every, and look, it's not the sine, it's not the cosine. So instead of it being in every 360 or 2 pi, it's in every 180 degrees or pi radians, right? So if you want a formula, the period equals, in the case of the tangent, 180 divided by the b value. Because look, if you get 3 in every 180, then the period of each wave must be 60 degrees, right? If you're going degrees, pi over 3, which is 60 degrees if you're going radians. And some of you guys still struggle with a fraction. You know, if you do the second one, if you took 180 and you divide it by 2/3, you guys realize it's the same as putting the 3 up on the top? I mean, it's just all it is. So all you're doing is inverting and multiplying, right? So it's 180 times 3 divided by 2, and what do you get for that thing? 270? All right, 270 degrees. So let's do them in radians as well, because we do have to get you thinking in radians. So if you go back to number 1, it would just be, again, instead of 180 over b, it would be pi over the value of b, so just pi over 3 radians. If you did this one, it would be pi divided by 2/3. And so what does that end up being? 3 pi over 2, right? Again, the 3 just comes all the way to the top. All you're doing is inverting and multiplying. Okay, so what about the cotangent? Well, the cotangent is just a mirror image of the tangent. The mirror image, the only thing is the asymptotes are at negative 180, 0, 180, 360, ... So the cotangent, your asymptotes, are 90 degrees out of phase. Okay, if you mirror something, that center point stays right where it is, right? So at negative 90, put the 0 point. So halfway between negative 180 and 90, instead of being at negative 1, now we're going to be at... So, okay, so watch here. Let me try to get you guys to follow what I'm thinking right now. So I'm looking at this point, right? I'm thinking this point for the tangent, halfway between the start and the midway point for the tangent is negative 1. So halfway between the start and the midpoint for the cotangent, it won't be negative 1, it'll be positive 1, right? It's the mirror image. Earth to daydreamers, not a good time. You're staring off into space. Okay, and I don't think you're thinking about what I'm saying. That means you back there, hello! All right, good. I know your eyes are wherever, and definitely not here, so. Right, the mirror image. So, again, if you look back at the tangent, from the halfway between the middle to the end is at positive 1. So the cotangent halfway between the middle and the end will be at negative 1, right? It's the mirror image. Tangent comes up from negative infinity and ends up toward positive infinity. The cotangent goes the opposite way. Starts at positive infinity and goes down through negative infinity. And you just repeat that if you're going to do the other ways. So both the tangent and cotangent are discontinuous. They have asymptotes. Their domains have values that the domain do not contain. So if you're going to write the domain here, you'd have to say set of all x is such that x does not equal, okay, 0, right? You can't have 0, comma, plus or minus 180, comma, plus or minus 360, comma, etc. Dot, 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 right? By the way, no plus or minus 0, because last time I checked, 0 is not negative. Okay? So that's the tangent, that's the cotangent. Look, if you forget, you can just punch in the values on your calculator, but it's easier to know the shape and understand what the shape does. That's the easiest way to do it. Okay, so what is the reciprocal of the sine? It is the cosecant. All right, so let's do the cosecant. I'll do it in blue. The easiest way to do the cosecant is to graph the sine. So do you guys see that here in red I have the sine function? The sine function is not the cosecant function, but the sine function allows us to graph the cosecant function. Okay, so that's our normal sine. My numbers are off. All right, let's fix this. So this is 180. Don't know what in the world happened there, but first additions of notes, that's 360. 460, 540, 720. And therefore then back here, this is negative 180. All right, I don't know what in the world I was doing there. Okay, normal sine function. Everybody with me? Again, normal sine goes 0 to 360. Halfway is 180, all the way is 360. So 180, 360, 540, 720, and back the other way is negative 180. I don't know what I was thinking. Probably I used something. Keegan.
The third one's to be 450.
Thank you. No Kool-Aid for Keegan. Is that what you were wondering, Thomas? I saw you like thinking, what in the world? So 364, 6, no, it's 540. Back to Kool-Aid. Sounded good, though. I was willing to buy it. Okay, so with having the sine, you're able to graph the cosecant, but really what we're going to do is sketch it. So we're just going to sketch the cosecant. All right, so let's go ahead and mark off the crests and the troughs. Just take your blue and put a point on the trough, that's the low point, and the crests, the high points. Okay, so let's figure out the cosecant of 90 degrees. Cosecant of 90 degrees. You guys remember how to do that on your calculator? All right, so with our calculator, cosecant of 90, and hopefully you're going to say that's the same as 1 over the sine of 90. Agreed? And your calculator says? It says 1. And that's exactly what we have right now by putting that point there, correct? And we could do the same thing at negative 90, at 450. We get negative 1 at 630, etc. Right? These points, if you punch them in your calculator, you would get them. All right, so let's see. That was 90. So what is this? 135? So let's do now the cosecant of 135 degrees. Punch that out, cosecant. So again, you're going to do 1 over the sine of 135. When you get that, somebody raise your hand and tell me what you get. Abigail, what do you got? 1.4142. Okay. 1 point. And if you look at the scale, so 1.4, each block is 0.5, right? Is a half. So we're probably going to be, let me get rid of my circle there. At least some of it. How about all of it? Beautiful. Okay, so 1.41 is going to be about there. Does anybody want to venture a guess at what 45 degrees will be? Because math is nice and symmetrical and, you know, beautiful. Hunter?
1 point.
Yeah, and you can punch it in if you want and do 1 over the sine of 45, and you're going to get the same value, 1.41. All right, let's go ahead and do 180. What is the cosecant of 180 degrees? Go ahead and punch that out. What'd you get? All right, is that what your calculators say these days? Divide by 0 error. Why does it just say infinity if it's going to say all that? All right, it's infinity. And so what ends up happening, go ahead and take your blue, this thing goes up toward positive infinity that way and up towards positive infinity that way. And that is only one portion of the cosecant. Now we have to do this from every point. So again, you can come down here and basically sketch it. We don't need to do all the points. And we're just sketching now that same shape from each of these maxes or mins. Well, that was an ugly one. You can do that from every max or min. And the one on the bottom left and the one on the top right is one complete cosecant. It's also got a period of 360 degrees, just like the sine does. So two of them, though they are they continuous? Discontinuous. Two of them, though they are discontinuous, make up one cosecant function. And it's periodic, right? It keeps going on forever and ever and ever and ever. So again, this one and that one are one of them. Whoa, okay. All right. Those two are one cosecant. Abigail. Yeah, if I ever ask you to say graph the cosecant, you need to show both the one going to negative infinity, the one going to positive, because both of them together is one cosecant wave.
I was talking about, like, you want it on, do you want it on the negative part of the x-axis and the positive part of the x-axis, or do you want them both on the same part?
Here's the thing with, I understand your question. Where do you want us to show it from? Normally when we ask you to graph a wave, we'll tell you go between thus and thus and thus and thus. So sometimes we'll say, well, we could say go between 0 and 360. If that's the case, then you would show that part, right? And if we said go between negative 90, which would be a weird one for the cosecant, we probably wouldn't say that, but anything's possible. I mean, that's what you'd have to show if we said go between negative 90 and 270. You know, it would look like that, just showing the portions of it. But normally we're going to give you a range and tell you graph it between this range. Okay? Luke?
If the B is like 2, is there going to be 2 of those in 180 degrees?
Yes. and you would double your asymptotes. Exactly. Exactly the case. Because it would correspond to the sine having two waves in every 360, which would have then been back to what I originally had the numbers written. Which I don't know why I wrote that. Again, because I copy and paste a lot, and I copy and pasted off of one that went the wrong way, and that's going to do the same thing that's going to happen on the next one. All right, so let's do the secant. It's the exact same concept. Unfortunately, I messed up the graph again with the amount of degrees, so we got to change that. So again, go back and change your degrees. The 180 is 360. The 90 is the 180. The 270 is the 540. And the 360 is the 720. And again, negative 90 is negative 180. So what am I doing? I'm showing you two cosine waves, right? And so the cosecant, or I'm sorry, the secant is the reciprocal of the cosine. And so look, math's nice and orderly. Look what the cosecant did in respect to the sine. What do you think the secant's going to do in respect to the cosine? Exact same thing. Notice we have asymptotes already shown. So now just take and put a point at, again, every peak and every trough, every max and every min. And again, we're just going to sketch. So you're just going every max, every min. Here, this time, let's just do one set. So I'm just going to go from 180, and I'm going to go from 360. And if I were careful, they would all look the same. The one on the top looks a little fatter than the one on the bottom. Oh, well. There, we'll get rid of that. Woo! Where are we? No one knows. Go back, wherever you are. All right. Fair enough. Woo! All right, now it's a mess. We can erase. Okay, so period again is going to be the same thing. 0 to 360. So now Abigail's question comes into play. Well, what if they wanted you to show between, what if we said show this between 0 and 360? You would have to include this half here, right? If we said between 0 and 360, because it would be, right, let me grab my pen again here. So because this would be between 0 and 360, right? Because of the way the cosine goes. So if we said show it between 90 and 450, then it would look more normal. You're not going to graph these tonight. You are going to read graphs tonight, but you're not going to graph them, so not a big deal. All right? So let me go back. What does a tangent look like? It's discontinuous. You have asymptotes. Be careful with the domain. Everywhere where there is an asymptote, that cannot be that value. So set of all x is such that x just cannot be these, meaning x is everything else. I'm not done. I'm going to keep teaching. I'm going to teach the next lesson here in a minute. And then cotangent, mirror image, but 90 degrees out of phase, so be careful there. Cosecant and secant, how do you graph them? Graph the sine and cosine, and then put the asymptotes through all the, by the way, look where the asymptotes go through. Right? Let's see, got to get out of my magic pen. What would you call that of a graph? That's a 0, and 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 the asymptotes go through all the zeros, which is the same thing here, right? The asymptotes go through all the zeros. If we were to change the period of the sine and therefore did the associated cosecant, we would change the period of the cosecant. Change the amplitude of the sine, then the cosecant would start higher, right? If we lowered the amplitude, the cosecant would start lower, because they always start from the peak and from the trough, from the max and from the min, always. 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 All right, I'm going to quit on this lesson, and as soon as it records,